Hello. Okay, so the purpose of this video is to kind of go off where we left off last class. It's a little extension on rational expressions. Instead, this one is in the form of a word problem. Okay, so let's say we have Kevin here. So Kevin can clean a large aquarium tank in about 7 hours. Okay, then we have, well, if Kevin and Lara here, so Kevin and Lara, if they work together, then they can clean the tank in 4 hours. Okay. What we want to do is we want to write and solve a rational equation to determine how much time, so time is variable we're solving for, it would take Lara. So we need to figure out how long she takes to clean the tank if she works by herself. Okay. So first what we want to do is I just kind of want to demonstrate what I showed you guys in class. Okay, so recall that we have work equals rate times time. We're going to use this in some sort of form to try and solve this. Okay, so first let's try to create a little table. Okay, so we have work, I'll just write it out, equals rate times time. Okay, and what I'm going to do is I'm going to go ahead and draw a nice little box here just so you can see what is happening. Okay. So what I'm getting at is we need to create something here. So we have Kevin, and then we have Lara, and then we have when they work together. Okay, so we have Kevin plus Lara. Okay, so the work is basically determined by, well, the amount of tanks that they can clean, right? So based on what I see here, so work is based off the number of tanks. So it says, and then time, as you can see here, time would be represented in hours. Okay, so let's go ahead and try to reason through it. So it says Kevin, so this is Kevin, can clean a large aquarium tank. So one tank in about 7 hours. Okay. When Kevin and Lara, so here, when they work together, they can clean one tank in 4 hours. Okay. Our goal is we want to solve, right, and solve a rational equation to determine how much time it would take Lara. So this is what we're trying to figure out. So if Lara cleans one tank by herself, we're trying to figure out how much time it takes. So we'll denote that by t. T is our variable that we're solving for. We don't know how long it takes. We know it takes Kevin 7 hours to clean one tank. We know if they work together, then they can clean it together in 4 hours. But if Lara works by herself, we don't know how much time that it takes her. Okay. This is where we're going to have to do a little bit of manipulation with this equation. So we have work equals rate times time. So what I see is we want to get rate by itself. So we get rate by itself, we can divide by time. Okay, and our goal is to solve for the rate. So time cancels, and we get rate equals work times time. So recall we did something similar like this in unit 0. So basically, what we're going to do is we want to try express our rates here. So what we can do is, well, our rate can be represented by 1 over 7, work divided by time, right? So 1 over 7. Lara's rate is 1 divided by t, and basically, if they work together, this is 1 divided by 4. Okay? So what this implies is the rational expression that we're working with is, so we have Kevin's rate plus Lara's rate, and that's equal to basically the time that they work on the tank together. So we have, or the rate that they work on it together. So 1 divided by 4. Okay. So what we want to do from here is we want to try and solve this thing. So 1 over 7 plus 1 over t equals 1/4. Let me go ahead and just take a screenshot of that and clear what we have. Okay, so this is what we need to solve. Okay, so what I see is, let's see. So we want to get all denominators to be the same, kind of like what I showed you previously, right? So I see this expression is going to be missing a 4 and a t here. So if we wanted to, we can start by multiplying by 4 times t, right, times 1 over 7 plus, and then we have 1 over t. We have the 7 and the 4 missing, so we can multiply top and bottom by 7 over 7 and 4 over 4. You just put 28 if you want, that's fine. And then this one, we have 1 over 4. We're missing the 7 and the t here. So we're multiplied by 7 over, I would put 7t divided by 7t. Okay. What we want to do is we want to try and simplify this. So we have 4t divided by 28t plus 1 times 7 times 4 is going to be 28 divided by, and then we have this is going to be 28t, and then we have 1 times 7t, and we divide that by 4 times 7t, and that's 28t. Okay. Let's see. And like I told you in the other video, right? We wanted to find our least common denominator. Our least common denominator in this case is 28t. So what that means is once we get all denominators the same, if we were to multiply this thing by 28t, so as you see, what's going to happen is basically what you're going to realize is that all of this cancels when you distribute, as you can see there. Okay, so what we're left with is we have 4t plus 28 equals 17. And then our goal is to solve for t. So we can subtract 4t from both sides, cancels, 28 equals 3t, solve for t, you divide by 3. And then t in this case is going to equal, well, 28 divided by 3. So 28 divided by 3, let's say I round that to the nearest hundredth. If I round that to the nearest hundredth, that's about 9.33 hours. So that's how long it would take Lara to clean the tank, about 9.33 hours. Okay, please let me know if you have any questions on this. Okay, bye. Hello. Okay, so it seems that I forgot to answer that part where it says, in the word problem, it says, explain whether the answer is reasonable or not. This will be reasonable because, as you can see here, what this implies here, we have 1 divided by t. This implies that t just can't be 0. Because recall that, what I mentioned in the other video, is if you get a denominator of 0, that's, if you divide by 0, that's something that's undefined. So in this case, 9.33 hours is not the same thing as 0 hours, so that just implies that it's a reasonable answer. Okay. All right, so now I'm going to show you a different problem. So I'm going to go ahead and clear the screen. All right, this is where the fun begins. All right, so let's say I give you something like x minus 1 divided by x squared plus 3x plus 2 plus 2x divided by x plus 2 equals negative 2 divided by x plus 1. Okay, so what I see here is what we want to do is we could actually factor this. Okay, I know some of you not very good at factoring, but it's back. So find two numbers that multiply to 2 and add to 3. Okay, so let's see. Well, I think 2 and 1 will work. So 2 times 1 is 2. 2 plus 1 is 3. Divide by a term, which is 1. So if we factor this, this is x minus 1 divided by x plus 2 times x plus 1 plus 2x divided by x plus 2 equals negative 2 divided by x plus 1. Okay, next, what I see we want to do next is we want to try and match up the denominators. So what I see in this case, this would be our least common denominator. It would be x plus 2 times x plus 1. So if we want to match up the denominators, so what I see what we can do, so I'm just going to write all these steps here. So we have 2x divided by x plus 2. We can multiply top and bottom by x plus 1 divided by x plus 1. And then that equals negative 2 divided by x plus 1. We're missing the x plus 2 in the denominator here. So we need to multiply by x plus 2 divided by x plus 2. Okay. So as you can see here, these denominators are all the same. So since they're all the same, essentially what we can do is we can multiply by x times 2 times x plus 1, which is our least common denominator. And what's going to happen is all these lovely denominators are going to cancel. So what we have is we have x minus 1 plus 2x times x plus 1 equals negative 2 times x plus 2. And then we simplify x minus 1 plus 2x. Okay, I'm just being a little lazy here. We're distributing here. So we have 2x squared plus 2x equals negative 2x minus 4. And then we can go ahead and try to solve for x. So I see a 2x squared. I'm going to put that in front. X plus 2x is going to be 3x. Then we have a minus 1 here. That equals negative 2x minus 4. Okay. What I see what we can do next is we can try to get all the terms on one side. So I see if we add 2x on both sides and we add 4 on both sides. So what we have is this cancels. We get 0 on the right hand side. We get 2x squared plus 5x plus 3. Okay. Couple ways you can do this here. You could use quadratic formula with a equals 2, b equals 5, c equals 3 and solve it. Or if you guys do not like using quadratic formula, you can try to see, well, maybe this is factorable. Just maybe it might be factorable. Let's see. 2 times 3 is 6. Bottom is 5. We need to find two numbers that multiply to 6. Two numbers that multiply to 6 and add up to 5. That should be 2 and 3. Okay. And then what we're going to do is we need to divide by our a term. So we can divide by 2. Okay. And then we can reduce this to 1 over 1. So if we're to factor this, this looks like it's going to be x plus 1 times 2x plus 3 equals 0. And then we could solve. So we have x plus 1 equals 0. Solve that, we get x equals negative 1. Then we have 2x plus 3 equals 0. Subtract 3 on both sides, divide by 2. And then we get x equals negative 3 halves. So these are our possible solutions that come out of this. Okay, but what we want to do is it's good practice to also go ahead and check to see if these solutions are actually valid. So what I see is that if I were to plug negative 1 back into here, like our original, negative 1 plus 1 is going to be 0. So recall that if we get a denominator of 0, that's going to lead to something that's undefined. This means x cannot equal negative 1. So since x cannot equal negative 1, we have to omit that solution. It looks like negative 3 halves is going to work no matter where we plug it in. I think it should be okay. The only other value where what x cannot be, I believe, would be negative 2. Because negative 2 plus 2 would be 0. Even here, if you anything times 0 is 0. So for negative 2 plus 2 would be 0, and negative 1 plus 1 is going to be 0. So these two values would be would make the denominator 0. So as long as our values are not any of those, we found that x can't be negative 1, but negative 3 halves should work. and that's our only solution that should work for this. Okay? All right, and that's basically it for this problem. All right, so I'm going to show you another problem after this. I'll see you later. Okay, bye. Hello. Okay, so I'm going to show you one more problem based on solving rational expressions. Okay, so we have something like this. 4 divided by x equals x plus 2 divided by x squared plus 2x minus 1/3. Okay, this looks a little complicated when you first look at it, but it's actually not that bad. Okay, what we see here, so it might be a good idea when you try to do some of these problems, try to look if you can see if you can factor anything before starting. So what I see here is something can be factored out. If you guys realize what could be factored out, the x is in common with each term. So we can pull out an x, we can factor out an x, and we multiply by x plus 2. And then minus 1/3. Okay. Next, what I see is we have an x plus 2 in the numerator and an x plus 2 in the denominator. So what that implies is this is going to cancel. Isn't that lovely? So what we have is, well, this is just 1. We still have a 1 in the numerator, so don't forget that. So when we have this, this is 4 divided by x equals 1 divided by x minus 1/3. And then we can solve this the way that we have been doing it earlier. So you can find a common denominator, right? So we can multiply this by 3 over 3. Let's see, we can multiply. So we have 1 over x multiplied by 3 over 3. And then this fraction, 1/3, we need to multiply by x divided by x. Okay, and then combine. 12 divided by 3x. 1 times 3 is 3, divided by 3x. And then 1 times x is x, divided by 3x. Our least common denominator in this case is 3x. Okay, so since that's our least common denominator, we're going to multiply by 3x. And what's going to happen is when we distribute, basically what's going to happen is this all cancels. So we're left with 12 equals 3 minus x, and then we just solve. So let's see, I can subtract 3 from both sides. So we get 9 equals negative x. I'm going to put this over here to finish it off. 9 equals negative x. We need to get x by itself, so I divide by negative 1. So what's going to happen is, yeah, this turns positive. And then what we have is negative 9 equals x. So in other words, x equals negative 9. Okay, now it might be good practice to also check to see if solutions are valid, right? So based on what I see here, again, what I look at here, x cannot be 0. And then I think x cannot be negative 2 either. If we put negative 2 in here, negative 2 plus 2 is going to be 0. Anything times 0 is going to be 0. So that means the denominator is going to be 0. So it just can't be 0 or negative 2. In this case, we got negative 9. And that means we should be okay if we're to plug x back in. Okay? And that's basically it for this particular problem. Okay? Please let me know if you have any questions. Okay, bye.